so tonight we're going to do graphing in slope-intercept form. So I can identify and graph slope-intercept form. So the first thing I wanted to talk about is the slope-intercept form again. And we've talked about this a few different times, y equals mx plus b, and that there are three different kind of ways to look at this information. We can look at the equation, which of course is what this is. We can do a graph, which is what we're going to talk about today, and then the problem or the situation or, however it looks in like a word problem or real life situation. So in an equation, we have m, and m represents the slope in a graph, and in a problem, it represents the rate of change. Okay. In the equation, we have a b, which is our constant term, and the constant term represents the starting point, or the beginning. Sometimes I like to call it the beginning because that matches my b over here, but it's the starting point. And then in the, oh no, I got that backwards. Sorry. In the word problem, it's the starting point. On the graph, it's the y-intercept. The y-intercept. There we go. So if I have these problems down here, if I want to identify the slope and the y-intercept, the slope would be the coefficient of x, which is 2/3, and then the y-intercept would be -4, or the constant that's on the end. Constant is the number without a variable, and the coefficient is the number with the variable. Over here I have a slope of 1/4 and a y-intercept of -6. Don't forget that that sign in front of there has to stay with the intercept, so it will be -6. Now, if we're going to graph something, we still want to find these two numbers, the slope and the y-intercept. Now, in this one, it's pretty obvious here. The slope is the y-intercept is 3, but the slope is a little bit confusing because it's not x, because remember, it's not the variable that's the slope, but the number in front of the variable. And while it doesn't look like there's a number in front of this variable, there's actually a 1. So my slope is 1. And I'm going to write my slope as a fraction as 1/1, which 1/1 is the same thing as a whole number 1. But since slope represents rise over run, I want to have that as a fraction. So even if it's a whole number, I'm going to go ahead and write it as a fraction. Now, to graph then, we're always going to start with our y-intercept because it, again, is our starting point. Y-intercept of 3 means that it's going to cross my y-axis at 3. So there is 3. And then I have a slope of 1, which means I'm going to do a rise and a run of 1. So if I rise 1 and I run 1, then I am at this point right here. And I really need more than 2 points, especially when they're that close together. So I'm going to do it again. Rise 1 and run 1. And that gives me that point right there. I can also go the other way, because remember, this is the same thing as -1/-1, because two negatives make a positive. Now, the reason I'd want to do that is so I can move the other direction. So down 1 and back 1, and here's a point. And they're all still on the same line. And there's the graph of my line. So it's really important to look at these two different ways that you can represent slope so that you can go to the right and to the left. Okay, let's look at this one. Graph y equals -3/2 x minus 1 using slope-intercept. So I'm going to find my slope and I'm going to find my intercept. My intercept is -1 and my slope is -3/2. And since I'm going to write this two ways, it also is 3/-2. Because the negative can go on the bottom or the negative can go on the top. Doesn't really matter, as long as one of the numbers is negative. So when I come over to my graph, I'm going to put a dot at -1, which is right down here. So it's going to cross my y-axis at -1. And then I'm going to do my slope. So I have a rise of -3. So I'm going to go down 3. 1, 2, 3. And then a run of +2 would be right there. If I want to do my other one, I'm going to do a rise of 3, 1, 2, 3, and a run of negative 2, which would put me back this direction. And there's my dot. Now, one of the reasons why I like to do, my line wasn't very straight, but let me draw that again. If you have a ruler, you really need to use a ruler to draw your lines so that it's nice and straight. I don't have a ruler. That's better. One of the reasons I want to try and get 3 points on here is to make sure that it's straight. If I put 2, I can always draw a straight line through 3 points. But if I do 2 and then I do a third one and it ends up over there, and that is clearly not a straight line, it kind of is a good check for me that something went wrong and that I need to go back and kind of redo my problem. So 3 points. All right. Now I have several different ones here we're going to look at. Y equals a negative 1/6 x and negative half. So I have a slope of negative 1/6 and an intercept of negative 1/2. Now this one I have a fractional intercept, which I need a graph. So I'm going to go back here and grab this graph here. Now, there's a couple of ways I can do this. I could just guess and put my graph or my half at, halfway in between, but which I think I'll probably do that because half's pretty easy to do. So a negative half is going to be about right here. But when I go to do my rise and my run, so I've got negative 1 over positive 6. If I go up 1, then I'm a half here. And then, oops, down 1, sorry. Down 1 here. And then a positive 6. 1, 2, 3, 4, 5, 6. Over this way. I end up right there. Then if I go the other one, I'm going to go up 1 and 1, 2, 3, 4, 5, 6 this way. So here we go. So that still works. I can still graph if I have a fraction. The other thing you could do is count up by halves. So it's going to make the graph look a little different. But if I count this as a half and this is 1, then when I do my slope, though, I have to be really careful because if I'm going to go up 1, then I got to go all the way up to here. And then 1, 2, 3, 4, 5, 6 is going to be way over there. So it's just going to make the graph a lot bigger. Oh, and it would have been positive too. So, all right, let's try a different one. Let's see what this one says. Negative 5x plus 3. So my intercept is 3, and my slope is going to be negative 5. Again, that's a whole number, and I want to write my whole numbers as fractions, so I'm going to put it over 1. My intercept is a positive 3, so 1, 2, positive 3 is right there. And then a negative 5 over 1. So I'm going to go down 5, 1, 2, 3, 4, 5, and then over 1 right there. This is going to be a pretty steep slope. 1, 2, 3, 4, 5, and back 1 gives me my other point. Oh, and again, that's really crooked. I need something that's going to draw me some lines. 1, 2, 3, 1, 2, 3, 4, 5, and 1. 1, 2, 3, 4, 5, and 1. Let's see if I have a tool up here. There we go. That's better. Now I have a better line. There we go. And there's my line. All right, one more. X plus 2. Slope and y-intercept. The intercept is 2. And again, I just have an x with nothing in front of it. So that means my slope is going to be 1. And I'm going to write it as 1 over 1. Okay, so my intercept is 2, 1, 2. A slope of 1 means I'm going to go up 1 and over 1. I can do negative 1 over negative 1 as well and go down 1 and back 1 like that. And then I can draw my line. And there's my line. And that is it for graphing with slope intercept.